Section 10.5, the law of sines. We've got a little bit of warm-up here that I want you to give a shot. It says find the area of each triangle, in this case just one triangle, with the given base and height. Well, actually there's two different problems here. So quick refresher, area, there's two different ways people think about it. The way I've always thought about it is 1/2 base times height. Some people also express it as base times height divided by 2. Doesn't really make a difference which way you go about it. So for this first one, there should have been a 1 there. My apologies. But we'll just do area equals 10 times 7 divided by 2. Well, that's 10 times 7 is 70 divided by 2 gives us 35. Or if you want to approach it the other way, the other one I'm just going to do area equals 1/2 times 8 times 4.6. Now, if you need to use a calculator for that one, totally understand, but you get an area of 18.4. Below that, we've got some proportions we're trying to solve for here. A couple different ways you can do this. One way, I'd say the most common way you'll see this done, is cross multiply and divide. So 12 over 19 equals 18 over x. We can cross multiply, so we got 12 times x, and then we have 19 times 18. 19 times 18 is 342. To solve for x, we can divide both sides by 12, and we end up with x equals 28.5. For this next one, same thing, cross multiply, we got 51x, and then 15 times 34 is 510. This one's going to work out pretty nicely. If we divide both sides by 51, we get x equals 10. Forgot to put some boxes around these. Bottom one here, I'm going to tweak, the format of this one. It might be correct in your digital copy, but this should say the measure of angle A. I just put things in the wrong order. So in triangle ABC, the measure of angle A equals 122 degrees. The measure of angle B equals 17 degrees. What's the measure of angle C? Now, if it helps you to think about this, actually drawing out a triangle. So let's just draw one out. That looks kind of like a right triangle, but we don't know if it is. So let's say that's angle A, that's angle B, that's angle C. A is 122 degrees. B is 17 degrees. We got to figure out what angle C is. Well, knowing what we know about the triangle, the sum of three angles in a triangle must be 180. So if we do 180 minus the other two, so we can do 180 minus 122 minus 17, or if it helps you to think about it this way, you can add up the 122 and the 17 first and then subtract. Either way, you're going to end up finding that the third angle is going to be 41 degrees. So a little bit of a refresher from geometry. Our goals, for this lesson, are to determine the area of a triangle given side angle side information. Oh man. And then use the law of sines to find the side lengths and angle measures of a triangle. Let's start with the first. So say we have a sailmaker and they're designing a sail that will have the dimensions shown in that diagram to the right. Based on these dimensions, the sailmaker can determine the amount of fabric needed. Now, the area of a triangle, we just use this, is 1/2 base times height. Now, although we don't know the height, h, what we can do is calculate it by either using the fact that sine of angle A equals h over c, so kind of putting this into perspective. Here's angle A, which would make that the opposite side, and this would make that the hypotenuse side. Or, kind of rearranging that, multiplying both sides by c, it'd be h equals c times the sine of A. So therefore, instead of writing area equals 1/2 base times height, we're going to replace the height with something else. We're going to say area equals, I'm going to use the word area here, area equals 1/2 times our base in this case, and then our height we replace with c times the sine of angle A. Again, since we just kind of solved for h there. So that leads into the area of a triangle formula. Now this works for a side, angle, side. In other words, we need to know two sides and the angle in between it. So the three options we have are the area equals 1/2 b times c, so putting this into perspective. B is down here, c is over here, times the sine of angle A. So angle A is in between b and c, so that's why we call it side, and then the angle, and then the side. Or if we're using a different angle, we can do 1/2 a times c times the sine of angle b. So here's a, here's c, angle b is in between it. Or we can use, depending on what angles we have, What area equals 1/2 a times b, so a times b, lowercase a, lowercase b, times the sine of angle c, that angle in the middle. So we're going to use this to help us find missing dimensions of a triangle. Looking at example 1, it says find the area of the triangle round to the nearest tenth. Now we need to label these things. My go-to is to label it like A, B, C. Not a big deal if you like use them in a different order, but how we label the sides is going to depend on how we label the angles. So if angle A is over here, side A is going to be the opposite to it. So side A is going to be the side that it doesn't touch. That means side B is going to be down here. Side C is going to be down here. So in other words, we know side A, side B, and that's an angle C. So we're going to use side A, side B, and angle C. We're going to use that variation of this formula. So we can say the area, let me zoom in, area equals 1/2 times B times C, sorry, goodness gracious, getting ahead of myself, 1/2 A times B times the sine of angle C. Now we know some information here. We got area equals 1/2 side B is, well, side A is 3 meters. Side B is 5 meters. And then we're going to do the sine of angle C, and that's 40 degrees. Now, we're going to type this into a calculator. Remember, making sure that our calculator is in degree mode. So we got the area, after we do 1/2 times 3 times 5 times the sine of 40 degrees, it's going to give us about 4.8. Now, I included the units here. We got meters times meters, so we're going to say meters squared. So we got to make sure we're in degree mode on our calculators. So that's just another way to calculate the area of a triangle.